Question number 8, we want to find the value of our function at C using synthetic substitution. This is on directions. We're going to use synthetic substitution, which is no different than synthetic division. So we're going to be dividing synthetically by C, which is 3. What we learned is that the f at 3, if we evaluate the function at 3, we'll get the exact same value evaluating the function. This function rule at 3 should be exactly the same as the remainder if we divide this synthetically. So synthetic substitution is synthetic division with the connotation or the idea attached to it that my remainder that I get will be the same as our function evaluated f at 3. So it's an alternative way of evaluating a function by using synthetic division. So I make sure I have all my coefficients: 4, -3, 1, -6, 8, -15. And now I'm going to divide synthetically. So to divide synthetically, I drop down my first number, which is 4. Take 4 times 3 is 12. 12 and a -3 is 9. 3 times 9 is 27. Add it to 1, which is 28. 3 times 28 is getting a little bit bigger. We're up to 84. 84 and -6 is a 78. Now I take 3 times 78. 3 times 78 ends up being 234. I add that on to 8. So 234 and 8 is 242. Now I multiply 242 times 3. That's 726. And now I add -15 and 726, which gives you a remainder of 711. This remainder is using our synthetic substitution to evaluate f at 3. So f at 3 is 711, but I'm establishing it through the use of synthetic division, which is termed synthetic division when we want to tie it to the remainder. So that's the process that was supposed to be used. You would get the same answer if you put f at 3 equals 4 times 3 to the 5th minus 3 times 3 to the 4th plus 3 cubed minus 6 times 3 squared plus 8 times 3 minus 15. And if you don't have a calculator, this is not very easy to do. It's probably a little bit more manageable to do your synthetic substitution, but that's the alternative that you can have. But on this one, I specifically wanted to use the synthetic substitution and link the idea to the remainder theorem.